The theorem on limit points, it is very important. If P is a limit point of E, then every neighborhood of P contains infinitely many points of E. So what is given to us that P is a limit point of E, right? And we need to show that every neighborhood of P contains infinitely many points of E. So we will show this result by a contradiction. For that, we need to suppose that the neighborhood of P is containing finitely many points of E. So let's start the proof for this supposition and then we get the contradiction for this, right? Okay. So suppose this is your set E and P is a limit point of E, right? And this is the neighborhood of P. Now we need to show that the neighborhood of P is containing infinitely many points of E, right? So if possible, suppose that this neighborhood of P is containing finitely many points. So suppose there is a neighborhood of P. NBD means neighborhood. So the neighborhood N of P which contains only a finite number of points of E. So let's say these green color points are finite in numbers. That are the points of E. So the neighborhood of P is containing finitely many points of E. Let's say this point be Q1, this point be Q2, this point be Q3, so on up to Qn. Right? So let Q1, Q2, Q3 up to so on Qn be the points of E distinct from P contained in the neighborhood of P. So the contained in capital N, that is the neighborhood of P. Now Q1 point is having the distance R1, Q2 point will be having the distance R2, Q3 point will be having the distance R3, so on, right? Let me consider this point, let's say Qi, right? It is having the distance from P to be equal to R. It is having the distance R from P, right? It is the minimum distance among all the points of N. जितने भी सभी points हैं, सबका अलग अलग distance है, but इस Qi point का सबसे कम distance है P से, right? So we are taking the distance R to be the minimum distance from the point P to this Qi, right? And this I varies from 1 to N. So it is greater than equal to 1 and less than equal to N. Is it okay? Fine? Alright. Now this Qi point is having the distance from P to be equal to R. If I consider the neighborhood of P to be having the radius R divided by 2, the half of this distance, right? So let me consider the neighborhood of P with radius R divided by 2. So I have considered this to be the neighborhood of P having the radius R divided by 2. Then there will be no point in this neighborhood. इस neighborhood के अंदर कोई भी point present नहीं है. Except P, there is no point in this neighborhood, right? But it is given that P is the limit point of E, right? This is your E. P is a limit point of E. Now what is the definition of limit point? Let's recall the definition of the limit point. P is a limit point of E if every neighborhood of P contains at least one point of E other than P. If this is your E and P is the limit point of E, then every neighborhood of P contains at least one point of E other than P. Let's say this be Q. There can also be possibility of the limit point on this set, but its neighborhood must contain at least one point of E. Let's say Q1. So according to this definition, our supposition was wrong. It is given that P is a limit point of E. It is given to us, right? And here we are saying, if I construct the neighborhood of P with radius R by 2, then this neighborhood will not contain any point of E, which means this neighborhood of P has only one point, that is P itself. But according to the definition of limit point, it must contain at least one point of E other than this P point. P के अलावा एक और पॉइंट भी इस नेबरहुड में होना चाहिए था अगर P उसका लिमिट पॉइंट है. So for this minimum distance R, that is the distance between the point P and Qi, we can construct the neighborhood of P with radius R divided by 2, and this neighborhood is not having any point other than P. So if I construct such neighborhood, that is, then neighborhood of P having the radius R divided by 2 contains no point of E other than P. So therefore what we can say about this P? Therefore this P is not a limit point of E. इस P point को E का तो limit point होना ही नहीं चाहिए. So which is a contradiction because it is given that P is a limit point of E, but we have shown that P is not limit point of E. So thus our supposition was wrong. What we have supposed is wrong. And what we have supposed? What we have supposed? We have supposed that neighborhood N of P contains only finite number of points of E. Right? We have supposed this. So our supposition was wrong. So hence, the neighborhood of P must contains infinitely many points of E. Right? So we have proved this result by a contradiction. I hope it is very clear, right? Okay, thank you. Stay blessed.